once we have a alkyl cyanide form, these cyanides can be changed into number of other functional groups. So alkyl cyanide is used as a important synthetic reagents. Now I will explain to you some important reactions of the alkyl cyanide. Now we are starting with this RCH2Cl. So I am using this Cl, and the first step is we are reacting it with ethanolic cation. It gives cyanide, RCH2 and Cn. So the chlorine has been displaced by Cn. Then we react this compound with a lithium aluminium hydride. Now this is a reducing agent. This step is called reduction of the cyanide, and the cyanide can be reduced to form a primary amine. This is called primary amine, in which the nitrogen is attached to only one carbon atom. This is called 1-degree amine. And this 1-degree amine on hydrolysis with nitrous acid, HNO2 is called nitrous acid, gives alcohol. And once this alcohol is formed on reaction with SOCl2, gives alkyl halide. But remember, this alkyl halide contains one carbon more than the parent alkyl halide. But we can also change cyanide into alkyl halide via this method also. Like we hydrolyze this first step using dilute sulfuric acid. So we write water and H plus ion. The cyanide can be changed into carboxylic acid. And this carboxylic acid can be reduced to form alcohol with lithium aluminium hydride. So it's your choice, either you convert chloride into another chloride with one carbon more via amines or via carboxylic acid. But remember that KCN can be used only with alkyl halide. Now if you want to step up, if you want to increase the number of carbon atoms in alcohol series, like suppose you want to convert ethyl alcohol into propyl alcohol, but you cannot use KCN with alcohol. So what we do, we first convert the alcohol into chloride, again using SOCl2 or PCl5. We have number of reagents available. Then follow the sequence of steps and you stop the reaction at the alcohol. So we can step up in the alcohol series. And if you want to step up in carboxylic acid, again we cannot use KCN directly with carboxylic acid. So what we do, we convert carboxylic acid first into alcohol like this using lithium aluminium hydride reduction. Then you follow sequence of steps and stop the reaction with the carboxylic acid. And if you want to step up in amine series, again amines cannot react with KCN directly. So what we do, we first convert the amines into alcohol using nitrous acid, and then we convert alcohol into chloride. We follow sequence of steps and you stop the reaction at the amine series. So you can step up in any homologous series, but via chloride using KCN. Like this is a sequence of steps. If you want to step up in alkyl chloride, so alkyl chloride to alkyl chloride you can step up. You can step up in the alcohol series also. You can step up in the amine series. and you can step up in carboxylic acid, but you can also cross the series. Now, what is the meaning of crossing the series? It means you can change one functional group into another with one extra carbon atom. For example, this is the question given: convert ethanol into propanoic acid. First of all, we write the structures. So we write CH3, CH2, OH, and our aim is to prepare propanoic acid with one carbon more than the parent alcohol. So we proceed via this flow chart. First we convert this alcohol into alkyl chloride using SOCl2 or PCl5. Then we use ethanolic ACN and we increase the carbon atom. And then we hydrolyze this using H2O in the presence of acid. So via this sequence of step, you can convert ethanol into propanoic acid, but this is a very, very important flow chart and you can perform number of conversions with the help of this.